Hello students, let's do geometry, fundamental concepts, exercise 17B. 17B is on page number 183. State which of the following is a plane closed figure. This is our first question. So we have many figures given and we have to say which of these is a plane closed figure. Now the first thing is when we see the word closed, we know that a figure can be called a closed figure if it's closed on all sides. That's the first thing. But there are some conditions also. A figure is said to be a plane closed figure. First, if it's closed on all sides like this. And secondly, if it is bound continuously by lines or curves. That means it's covered continuously by lines or curves. And another very important condition, these curves or lines should not intersect each other. So look at this figure. Here you can see a figure which is completely closed on all sides. It's bounded by curves, it's bounded by a line and nothing is intersecting each other. It's continuous, isn't it? It's continuously going. So this is a plane closed figure. The first one is a plane closed figure. Look at the second one. You can easily say this part is not covered. It's open. So it's not a plain closed figure. Third one. It's covered on all sides. It's bounded by lines which are moving continuously. So this is also a plain closed figure. Let's go to the other figures. Now here we have other figures. Look at this circle. This circle is a plain closed figure because it's bounded by a curve. So it's running continuously. So this is a plain closed figure. Now look at this figure. This is closed on all sides, but you cannot call this a plain closed figure. And what is the reason? Can you see there are lines inside intersecting? That means this is not going continuously, isn't it? The lines or the curves should move continuously and they should not intersect each other. Here you can see that they have intersected each other. So this figure, the fifth one, cannot be called a plain closed figure. Question 6. This figure is closed on all sides and it's bound by lines that are moving continuously. They are not intersecting each other. So question 6 is a plain closed figure. Now question 7, look at this figure. It's very clear. It's open on one side. So this is not a plain closed figure. Look at figure 8. This is closed on all sides, bounded continuously by curves or lines, and there is no intersecting of anything. So this is also a plain closed figure. So what are plain closed figures? They should be closed on all sides and they should be bound by curves or lines that are moving continuously and they should not intersect like this. Lines or curves should not intersect each other. Though this is fully closed, because the lines are intersecting, we cannot call them plain closed figures. Such figures cannot be called that. Question 2. State which of the lines or line segments are perpendicular to the line PQ. So first of all, let's look at the line PQ. This is line PQ. This long one is line PQ. Let's look at the first line. This is a line AB and cutting this line at 80 degrees. Then we have a line segment CD. How do we know this is a line segment? There are no arrowheads on either side. So this is a line segment of a definite length. So this line segment is cutting this line PQ at 90 degrees. The next line is line EF. This is a line segment cutting this big line at 60 degrees. Then we have a line MN cutting this big line at 90 degrees. So we have four lines or line segments cutting this long line PQ at different points. Now the question is, which of these are perpendicular to the line PQ? Now what is the meaning of perpendicular lines? Perpendicular lines are straight lines that cut another straight line making an angle of 90 degrees. Can you see this 90 degrees? If they cut another line at 90 degrees or at right angles, then those lines are called perpendicular lines. Let's look at this first one. AB is cutting the long line at 80 degrees. So AB is not a perpendicular line. Now here CD is cutting this long line at 90 degrees. So CD is perpendicular. We call it perpendicular to the line PQ. So CD is the first one. So let's just put a tick over that. CD is the first one. Let's look at EF. EF is cutting this long line at 60 degrees. So it is not perpendicular. Look at this line MN. It's cutting the long line at 90 degrees. So this is also perpendicular. So what are the two lines or line segments that are perpendicular? CD and MN are perpendicular to the long line PQ because they are cutting that line at 90 degrees. So can you see both are cutting at 90 degrees? So the answer is CD and MN are perpendicular to line PQ. Question 3. Which of the following figures show two mutually perpendicular lines? Now what is the meaning of perpendicular first of all? Perpendicular lines are lines that cut another straight line at 90 degrees like this. It's cutting this line at 90 degrees. Here also it's cutting at 90 degrees. And what is the meaning of mutually perpendicular? That means both the lines have formed 90 degrees between them. So this line has formed 90 degrees. This line has also formed 90 degrees with the other line. So when both the lines form 90 degrees or cut each other at right angles, they are said to be mutually perpendicular lines. So this you can see 90 degrees. So the first figure here is forming 90 degrees here, the angle. So these two lines are mutually perpendicular to each other. Second figure, it's forming 70 degrees, so they are not perpendicular to each other. Here it's forming 90 degrees. Both are straight lines, especially when you have this L shaped, you know that they are mutually perpendicular to each other. So we can say when both the lines intersect each other at right angles, then the lines are called mutually perpendicular lines. So here figures 1 and 3 are mutually perpendicular lines. Question 4. For each figure given below, name the line segment that is the perpendicular bisector of the other. Now we know what a perpendicular line is. A perpendicular line is a line that cuts another line at 90 degrees. Now what is a perpendicular bisector? So a perpendicular bisector, there are two conditions. First, it has to be perpendicular, that is make an angle of 90 degrees. What is the meaning of bisector? Bisector means it should cut that other line into two equal parts. It can't be anywhere on that line. It has to pass through exactly the midpoint of the other line, cutting it into two equal parts. Now let's look at this figure. There are two lines. We have A, B and C, D. Now AB is passing through the line CD, and can you see one stroke here? It shows that this line has been cut into two equal parts. So this part PD and the other part PC are of equal lengths. That means this line AB has cut the line CD into two equal parts. Then you can call it a perpendicular bisector. So this is a perpendicular bisector. Now look at this one here. Here we have line MN which is perpendicular to AB. But AB, there are no strokes on A and this line AB. Whereas there are strokes on the line MN. That means this line AB has cut MN into two equal parts. That's why we have two strokes. That means PN is equal to PM. How did that happen? Because AB cut it exactly in the midpoint at P and it's forming 90 degrees also. That square or that box there means 90 degrees. So here also AB is the perpendicular bisector of MN. So MN is a line that has been cut into two. Here also CD is the line that has been cut into two equal halves. So let's write AB is the perpendicular bisector of CD. So AB has cut CD into two equal halves. Similarly for this one, AB has cut MN into two equal halves. So that is called the perpendicular bisector of MN. Now here we have two more figures. Now look carefully and see. RS has been cut into two equal halves. PQ also has been cut into two equal halves and there's an angle of 90 degrees. That means both these lines are perpendicular bisectors of the other line. That means PQ has divided RS into two parts. So PQ is the perpendicular bisector. Now RS has passed through the midpoint of PQ, so that is also the perpendicular bisector. So here the answer is PQ and RS are both perpendicular bisectors to each other. Now let's look at the next one. Here the line CD is perpendicular to the line AB. How do we know? It has formed an angle of 90 degrees. But can you see it has not passed through the midpoint? It has not divided these two parts into equal halves. It has not divided these two parts into two equal halves. So here there is no perpendicular bisector. So you can say no line is a perpendicular bisector to the other. Remember, if they're perpendicular bisectors, they should pass exactly through the middle. But this is somewhere else. The middle is here somewhere, isn't it? So it should have passed through the middle. But this is somewhere else. So no perpendicular bisector here. Next one, look at this one here. Here, this line CD has cut AB into two equal halves. But has it formed an angle of 90 degrees? No, it has formed an angle of 80 degrees. So there are two conditions. If it has to be a perpendicular bisector, first it has to cut the line at 90 degrees. Secondly, it has to divide the line into two equal halves. So here CD has cut AB into two equal halves, but it has not formed 90 degrees. So here also we don't have any perpendicular bisector. So no line is a perpendicular bisector to the other. Question 5. Name three objects from your surroundings that contain perpendicular edges. Okay, now if you look at this slide itself, can you see there is one straight line here. It's cutting this other line at 90 degrees. So the edges here are perpendicular. Similarly here and here and here. Now you have to look at objects from your surroundings, what you have or what is there around you. So first you can look at the blackboard, isn't it? In your class you have a blackboard. Look at the blackboard and can you see these edges are touching each other at right angles? That means whenever you have an L-shaped formation, you know there is a right angle. So this is where you have the perpendicular edges. Similarly here, here and here you have perpendicular edges. Then if you look at your set square in your geometry box, you have set squares, isn't it? So you have a set square like this, and here you can see 90-degree formation, L shape here. You can see an L shape. This is a set square, and this is where you can see the L-shaped formation. So here and here you have perpendicular edges. Then look at the clock. Look at the arms of a clock. So when you get 90 degrees like this, then you can say that the arms of the clock are also perpendicular edges. You can look around and find many more perpendicular edges in your notebook, in your ruler, the windows, the doors. Okay, you can find these edges which are perpendicular to each other. So the corners of a blackboard, the sides of a set square, and the arms of a clock contain perpendicular edges. We are asked to name three objects. You can name any three objects. Question 6. Place a scale or a ruler on a sheet of paper. Hold it firmly with one hand. Then draw two line segments AB and CD along the longer edges of the scale. So first let's place a ruler and hold it firmly. So this is a ruler. Now draw two line segments along the longer edges. So this is one long edge and this is the other long edge. So draw a line here, name it AB, A and B. So we have drawn one line in the longer edge. Now they're asking us to draw one more line here. So let's draw that. So and let's name it C and D. So now we have drawn two lines. We are asked to state whether segment AB is parallel to or perpendicular to segment CD. So we have a line segment AB here and a line segment CD here. Are they parallel to each other or are they perpendicular? What are parallel lines? Parallel lines are two lines that will keep going without touching each other. Okay, and perpendicular lines are lines, that is you have one straight line like this and another straight line forming an L shape cutting each other at 90 degrees. But as you can see, AB and CD are not touching each other at all. They're just going straight continuously. So here they are line segments, but they're not touching each other. So what do we know about them? That they are parallel to each other. So the line segment AB is parallel to line segment CD. So this is the symbol for parallel lines. So this is how you can write.